Good morning. Wow. Actually more awake than I thought on an early morning here. That's great. So I want to start you off with a little bit of a story. Imagine you're not here, you're back at work, unfortunately. And while you're at work, you realize someone gave you a phone call about a production outage. So things aren't going so well. Something you wrote went down somewhere, and you and your team have to deal with it. So you're back there, you're working on this production outage, and then you start digging into the code to do some debugging. And after a while, you find some interesting code that really brings you to what the problem might be. Now, you weren't happy to be there in the first place, but you read something that was rather different. And it said, "Dear developer," right in the code. If you're reading this, there may be an outage. Well, yes, there is. We found some logs that can crash the server when they're full. So we added this line of code. If you remove this code, put it back. Now. And then you see the following code, something like this. Now, this little bit of code was removed through a GitHub comment that you saw in the history, and we put it back, and everything is back to normal, and you get to come back to the conference. But the question is this something we could have resolved? Something that we could have foreseen? Is this a good comment or a bad comment? How long did it take us to discover the problem? Was it helpful in discovering the problem? That's what we're here to talk about today. My name's John Papa, and I work for Microsoft. I'm a developer advocate. I'm a web developer, and this is Readable Code. So where do we spend most of our time? Do we spend it writing code or in reading code? Let me ask this a different way. When your friends and neighbors ask you what you do for a living, what do you tell them? I write code. Well, let's tell our neighbors and friends our dirty little secret. The actual reality is we spend about 10 times the amount of time reading code, not writing it. So we're actually a bunch of liars, right? Thanks to Uncle Bob Martin, great comment in here. And a lot of research proves this out. We tend to read much more often than we write. Whether it's reading your own code that you wrote yesterday that you forgot what you wrote, or you're reading your neighbor's code, or you come in as a consultant and you're dealing with somebody else's code. We're reading code all the time. So it's important that our code reviews don't look something like this on the right-hand side, and they look more like something that's on the left-hand side. It's not about creating really clever, crafty, pretty code. I mean, we all like it when we do something really creative, but it's about communication. Code is communication between people. The machine will do whatever we want. The computer doesn't care that you have a nested ternary function, which, by the way, if you do that, don't work with me, please. But people have to read the code that you write. So if you can read it quickly, that's important. And the way you communicate with people is just as important the way you communicate with your code. So it's about caring about the developer who's behind you. If this is you and you're working on your code, you may not like the developer behind you running at you with a bat. We always talk about make sure you code like the developer behind you is a psychopath coming after you. So we got to be careful about the way we're coding. Instead, we want a situation like this. We want to care about the developer behind us, because that developer might be you. Caring is a good thing, but leaving long-lasting code and what happens after, it's much, much more important. So how do we measure this productivity? Over time, in a lot of developer shops, you'll notice that the motivation to develop new projects, like to restart from scratch, gets higher and higher. Why is that? A lot of times, you can calculate the cost of complete mess just by looking at the quality of the code and the refactoring. A lot of times, we refactor from scratch because we can't figure out what's happening anymore, and it gets too difficult to update someone else's code, so we decide, it'll be faster if I just did this from scratch. We've all said this to ourselves. And then we rewrite the apps. Our teams are all happy because, yay, we get to use the latest Vue or Angular technology out there, right? And then your boss is like, no, it's not how I want you to feel. So who's the code intended for? The code's intended for people to be reading it. Machines just happen to execute it, but it's for people to be reading this. So that ratio, again, remember that as we go through these different tips that we'll be walking through, because you don't know who's going to be looking at your code. It could be you. It could be someone behind you. It could be somebody at the table with you. You never know who's going to be looking at it. So how do you make your code easy to read? Here's some tips that I have. First, start with some kind of a style guide. I wrote one like this for the Angular team a couple of years ago, and it worked out good. And the point of a guide is not to get rules in place everybody must follow, otherwise you shame them into submission. It's to have a starting point, to have an agreement with your teammates or at your company or your open source project of this is how this project will look and feel. 4 spaces, 2 spaces, editor config files, using prettier, whatever your particular styles might be, naming conventions, everything that you want to do. Having a style guide helps. And the guide shouldn't just talk about what it should do, it should talk about why you chose those things. The why is important because it provides context for other developers into how you're thinking, which is really important. For example, meaningful names are nice to have. We all know what this function does. It's doing division. But wouldn't it be a little bit easier to read if we just named things out very explicitly? We're dividing, passing in the dividend and the divisor, and then you get a quotient. Make it less difficult for somebody to read your code. We can also put functions and methods in here. Naming objects well, naming functions well helps make it easy to read. The read speed is crucial in determining how quickly you can pick up someone else's code. Often I'll be called into a shop to look at someone else's code. Sometimes the person who wrote it isn't even there anymore, and I'll have to very quickly diagnose what's going on. And to do that, it makes it a lot easier if you can understand the convention and get inside the mind of the person who is writing the code. And the less you have to assume things, the better off you are. So I like to have this rule with my children. I have 4 kids. My parents taught me this. If the food hits the floor and you count to 5, it's still edible before you pick it up. Same rule applies to code. So if we look at this code here, and you had 5 seconds to figure out what it does. See if you can determine that. 1, 2, 3, 4, 5. Probably not entirely, but you might get an idea of it. Now here's the same code, a little bit more legibly written. In this case, we're writing the code. It says, go get my sessions. Use the service to get the sessions, and then when they come back, map them, do some transformation, log the sessions out with any errors if there were, and show a toast when it's done. A little bit easier to read. A little bit of care and time by abstracting into functions and good names makes it much more readable. There's a term in marketing as well called above the fold. We can apply this from marketing and newspapers to computers. What it means is that what's above the fold of the newspaper is the part that somebody's going to more likely to read. On our computer screens, when you go to a web page, you're more likely to read the stuff that's above the fold where you don't have to scroll. When we code, we're more likely to read the things that are on top. So how do we take this to our advantage? We put the most important information first. We can look for signs that'll help us make this more legible as well. So to organize for readability, some tips that I like to do, and again, it doesn't matter what you put first specifically as it is why you put it first. I like to put properties followed by methods up top. It's just a convention. You can pick your own. I then like to make sure everything's grouped and sorted by similar types. And I use white space as a friend, not an enemy. It's not the idea to cram everything in, but to use it well enough so you can separate things out to make it legible. A good color theme will also help you improve readability. Pick whatever works for you and your team. Smaller functions, we heard about this for years, are more readable than longer functions. I once had a team come into me and say, John, you've been telling us to write unit tests for years, and I want to admit my team just doesn't do it. They just won't. And I said, well, why? They said, well, they don't know how to test the code. And I said, why? They said, because the functions are all 1,000 to 2,000 lines long. I said, why? And they said, well, because there's a lot of if-then logic and a lot of branches. Some of these branches have 20 different ways to get through the function. I said, why? And they said, well, I guess because we decided it was easier to write it all in one place and not break it out. I said, well, why not break it out? They said, well, let me try that. And they came back the next day and they had rewritten the code and actually had less than 2,000 lines of code and about 50 different functions at the end. So they broke it out into smaller functions, smaller units, got rid of all the comments, oddly, because they didn't need them anymore, and the code is much more readable to read. So in this one here, we can see you got updating, adding in one function. That's not too hard to read, but why not break 2 functions out? One for adding, one for updating. And then you can easily tell which one's happening, which one's doing which. Little changes like this can make your code much more readable, especially when people update your code. This applies to the new world with serverless functions in the cloud. Whether you're using AWS Lambda or Google Cloud Functions or Microsoft's Azure, all of those have serverless functions you can use. They set up the server for you. You don't have to worry about configuration. We just write the code. And these functions are optimized to be short and small, get in, get out quick. So we might have a function like this, which is a module style for ECMAScript. We call in, we export our function out to get a list of people, we parse our body. Notice that we're also importing a service from another NPM module. Could be module rewrote, could be a module that we pulled in from NPM. Abstracting out different pieces of code in different modules works very well for serverless functions too. So these rules don't just apply to the old world, they're applying to the new world where we're heading in the cloud. It's a great way to promote that reuse and reusability factor. So some of the advantages here is it's more readable, more reusable when we break things out into smaller functions, much easier to isolate and debug issues, also easier to refactor and to share models and services. There's a couple things to be careful of too. Just if you're having a lot of small functions and they're in multiple projects, it could be hard to track across different solutions. So just be careful that it's still easy to follow. Sometimes we can over-normalize or over-abstract. So there's a good balance to have. And always test for performance. Serverless functions, as I said, is a great way to deal with this, related libraries or microservices for abstracting out small functions. So what's my rule? I like to have like 20 lines or less of code. Because if there's 20 lines or less, I feel like I can always read it, even if there's a small screen that's out there. I say there'd be dragons because it could be 30 for you or it could be 10 for you. It really depends upon what your appetite is. Again, create a style guide with your team and figure out what it is. I'm just absolutely sure it's not 2,000 lines of code. So having a list like that of 20 lines or something like that will help you out. You can use linting tools for it. I used to work at a company that was multicultural, very diverse company, people from every country in the world working there, very large corporation. And most people did not speak English as their first language, and we coded in English. And there were a lot of misspellings in the code. The problem with that was sometimes misspellings were intentional, and misspellings can be important in your code. So, for example, I was just recently in Greece, and if somebody told you I love geek food, it sounds like it's a word, it sounds like it might be a thing, and you're not sure what it is, but maybe they meant to say I love Greek food. One letter can make a difference. This code, you might say who cares, but this code that I'm about to show you actually appeared in some code at that place I just mentioned. So here, we're saying add customer, get selected item, and notice how we spell rules and validate. Rules, R-O-L-S, valid 8, like the number. Now, the person who wrote this told me they thought it was just really funny. I'll tell you why it wasn't funny. I was asked to come in and change all the validation function in the project. So first thing I did is searched for Command F across my project, validate the word to do validation. Did not find this, we went to production, the validation for this was not caught, and therefore we had a bug in our program. Afterwards, the developer was laughing with our director, and the director's like, I don't get why this is funny, why can't you spell that right? So cute and clever was fun at the moment, but it didn't really work when we have to do Command F, because let's be honest, refactoring still involves a lot of search and replace. So things like this can really be make things hard to read. So spelling doesn't matter. It makes it easier just to spell things the correct way. And choosing a convention, any convention, doesn't have to be one that you find on the web, is always important. For example, I often see people struggling with, how do I call and name my functions? Do I say get the customers, fetch the customers, retrieve the customers, give me the customers? What is it? It's a lot easier if you don't pick 5 conventions and instead you just pick one convention. When you pick multiple ones, it makes it difficult to follow context. Picking the same one makes it easier to follow. Again, pick whatever your favorite is and follow it. That's a convention. The one thing we all struggle with as developers to realize too is that context of when we wrote the code is lost upon other developers. Have you ever heard a funny joke, at least you were told it was a funny joke, And then at the end, you're just looking like, I think I'm supposed to laugh, but I don't know if the joke is over. Usually that happens because you don't have the context. You lost something along the way. 3 developers walked into a bar. That's it. Great, what happened? I don't know. If our code doesn't have context, which is very difficult to do, it's hard for somebody else to pick up the code and read it. So context equals clarity. In this case, you may have seen this movie. You may not. There's a key inflection point in this movie that this, in the whole series, really dictated how everything else went. Darth Vader is declaring to this guy over here, Luke Skywalker, that he is his father, and he's not too happy about it. What if you've never seen that movie? Does this moment mean anything to you? No. If you have no idea of why this is important in the movie, and if you haven't seen it, you're like, yeah, I don't get that, John. That's the point. Without seeing the movies and understanding the backstory, you don't realize why it's so important that this guy had declared that he is his father and that's his son. So with that, if you tune at that scene, you lose all the context. You have no clarity of what's going on. You probably would tune out in the movie, not watch it anymore. So we need to make sure we provide clarity in our code so people can read through it. So one way to do that is to explain in code, not in comments. Here's an example. We're going to check if a hero can defeat a villain. And here's our logic using multi-statements with ifs. So we're checking all these conditions. And the comment is there, and this comment is arguably useful. But wouldn't it be a little bit better if we just had a function called hero.canDefeat, and then you add in the villain? A little more readable, less comments. And what happens in this code over here if someone changes the logic and they forget to update the comment? That could actually be worse because now you've got comments that don't match the code. So writing it out with self-describing code is always helpful. Always opt for self-describing first. Replacing magic strings with constants can help as well. Here we've got several strings for APIs and other events. Pulling out those into constants and then pulling them into a function makes it much more readable. Comments are something, they're technical debt that you have to maintain. So it's important that we keep them to be readable as well when we do have comments. So when don't we comment? Rules of thumb are when you're explaining what something does. Here's the beginning of an if statement. Here's the end of the if statement. Why, thank you. The if didn't give that away to me. Things like what is happening. The code tells you what already. Outdated, incorrect. Can't tell you how many times I've walked into code, looked at the comments, and the comments don't even apply to anything that's in the code. Because people refactor code and the comments always get left behind. Or you should have just used a well-named function like the canDefeat for the heroes. When are comments bad? Remember this code I showed you a little while ago? Actually, this isn't the same code. This code is now written to see if the villain can defeat the hero. But the comment was never updated. So this might be misleading to you as you're walking through your own code saying, why isn't this working? You're reading the comment, you trusted yourself with the comment, but you led yourself down the wrong road. So in this case, comments can mislead. A good friend of mine, Burke Holland, said this on Twitter last month, and I really liked it. He's like, code never lies, but comments sometimes do. The code will always do what the code does, but the comments do not. So we must keep those up to date. They should capture intent of what the code's doing. Not the what, but the why. Remember that first comment we had at the beginning of the presentation. The why. If you remove this, bad things will happen. The poltergeist will come get you. So when do you use comments? When it's explaining why something's happening. Unexpected consequences are important too, like the first scenario. We don't know why this happens, but if I don't open up at least 4 handles on this particular function, something will break. We'll figure it out later. Keep it here for now. Put a to-do in. Or API docs. You're creating and generating API docs with Swagger or other tools using JS doc format. Absolutely great reason to use comments in that situation too. Comments will help you out as well with situations where it's just almost impossible to read the code and understand what's happening. Even with validate email as the name of the function here, and naming the regex as email regex, looking at that regex, it's not obvious of what we're testing for or why in the email. Will this trap an empty email? Is that valid? Do we want to make sure there's a certain domain on it? Do we only accept certain character lengths? None of that is explained clearly here, and nobody in their right mind can read regex that quickly and figure out what's actually happening, right? So this is a great place for a comment to explain what's happening and why up top. The function says what, the comments say why. Because regex just happens. You know what they say, if you have a problem and you solve it with regex, what do you have? 2 problems, exactly. So always keep your comments up to date. It's our burden to maintain comments. If the comments aren't up to date, delete them. It's better not to have something there if it's going to mislead you than it is to have something incorrect in your code. Maybe you know it's incorrect and you're going to come back for it, but the next developer might not. Code formatting is also important. How many times have you been with your team and you get with the team and you're deciding on tabs or spaces or 4 or 2, or semicolons or none? Anything you can get into can get in an argument in this developer world, and we seem to fight over everything. Is GitHub good with Microsoft or not? That's yesterday's Twitter stream, right? So everything has some discussion in our place. One of the things we shouldn't be discussing anymore is code formatting. Why? Pick a convention with your team, use a tool that does this, and avoid all the problems. There's tools like Prettier that will just solve this for you. White space issues, unique styling per developers, naming requests. All this stuff can be solved with tools like Prettier. Set up your Prettier RC file, put it into your source code, up in GitHub in control, and then everybody can just pull it. Decide on it up front with your team. Don't just surprise your team with it either. Teams don't generally like those kind of surprises. So after all this, you might be feeling a little bit bad saying, wow, I do at least one of those things up there. John's telling me I'm not that great of a programmer. No, not at all. And I'm also not telling you that we can't do these things. In fact, I firmly believe that we should all write dirty code to start. It's okay to start off with code that doesn't follow everything, or anything for that matter. Get it working, get the ideas out of our head, onto the screen as quickly as possible. Iterate. In short, write your dirty code, and then refactor and clean it. Write your code, refactor, reclean it. Makes it a lot easier to walk through, and it also helps you get the ideas out, and it trains us to make sure that we can then make sure the code is readable after we get it on the page. So when we're done, we can go back to that comment again. Was it a good comment? I believe it was. It helped diagnose the problem. Without it there, probably would never have noticed why it was bad to remove that line of code. Writing readable code can make your code easier to maintain for that next developer who almost certainly is going to be you someday. So some of the tips that we mentioned here today, just to think about, are the 5-second rule. When looking at your code, is it easy to read through? Is it really quick to pick something up? Show it to somebody else and don't say a word. Observe their facial and body expressions as they look at your code. That will tell you more than the words, in fact. When somebody else looks at your code, what are they doing? One thing per file is always helpful to have, especially with node modules. Small functions, even more important now in the serverless cloud world. Well thought out naming, comments using wisely, crafting a style guide, and using tools like Prettier. All great tips that we can use in writing our own readable code. And if you want any links to any of these resources, here's a couple that are up there. If you want to try out functions on serverless functions, you can get a link here to try them out for free. I like VS Code as my editor. It supports all this Prettier and code formatting. Atom, WebStorm, Visual Studio, IntelliJ, all other great editors as well. Choose your own. Shouldn't matter these days. Prettier supports them all. If you're using Angular, which is one of my favorites, I wrote a couple extensions that are in this extension pack for VS Code. The WebStorm team has also borrowed many of those. We talk about to each other a lot, and they put them into their product as well. So you can get some of this code formatting to follow conventions. And if you like a good coding theme, the one I use is called Winter is Coming, named after Game of Thrones. There's a dark and a blue version of it, which I happen to like. They help you kind of get good color syntax changes. I highly recommend you take a look at different themes that are in different editors. Certain people have better accessibility with different themes as well. Pick one with your team. And finally, I want to mention that there's going to be a free meetup tomorrow night. It's part of the Angular Vue, PWA, and Frumzia combined meetups. And we're going to talk about a lot of great stuff about how to deploy Angular and Vue to the cloud. This is a free event. There's a couple seats left. Right, Max? Yes. Couple seats left up there. It's going to be free, a couple hours worth. And we're going to talk about VS Code and show a whole bunch of tips on how to use that as well. So please, give it a shot and hopefully you all go out there and write some great readable code. Thank you.
We'll just go over here. All right. So bright.
Yes, it is.
Can't see anything. So thank you. That was wonderful. Thank you for emphasizing that we cannot remove the human element from what we do.
Very
Try
true.
as we might. So I am wondering, are there other good examples? You mentioned Angular, but are other good projects or teams you see out there that people can look at that have written these code standards and style guides and stuff like that?
Well, I think the first place a lot of people like to look, and I gave a nod to Bob Martin in a couple slides in there, there's a book he wrote called Clean Code, which slightly different variation from Readable, but I think it's a great starting point for people to read through. Like any pattern or guide, you're not going to agree with everything, but I think it's a great idea to get a foundation of what clean code should look like.
Yeah.
As far as programs that are out there, I know the Vue team. I work with Sarah Drasner and know Chris Fritz and them. They wrote their own style guide as well, based upon the idea of what we did with Angular. And they wrote one for Vue that kind of shows how they feel like it's a good style and pattern to do that. There's some folks working on one for the Node projects now too, which is great. I think it's great that people are starting to put these together, and putting them in GitHub makes it easy.
Yeah. Excellent. Let's see. All right, and then, well, I guess if people wanted to get started, then these are good places to start, is look at what other people have done and get started and propose it to your team kindly and not in an abrupt way, forcing it down their throat, right?
I think that's really important. When you just spring something on a team, and I've done this in my past, made errors with this, springing it on a team is never a great way to get a good response. Always look at it as, what is the goal of what you want? If what you want is for them to work with you and to have a convention, the goal is to have one, then think about what it would be like if somebody came to you and said, here's 100 things I want you to start doing tomorrow.
Right.
Or would you rather be like, we should have a convention. Don't you think it would be nice if we all did stuff consistently? They're like, yeah. Well, maybe we should have a guide. Should we sit down and discuss this? Yeah. Well, you know, I have some notes on things I've been thinking. Could you get your notes together and maybe hers and his? And if you do it a little more, it takes more time to be kind.
Yeah.
But when you do it that way, I think you end up with a better product too.
Right. Great. All right. Thank you so much.
Thank you.
Everybody, round of applause for John Papa.